In this video, we're going to go over logarithmic differentiation. So let's begin. Let's say if you want to differentiate a natural log function with respect to x. So let's say if we want to find the derivative of ln u. The equation that you need to know, it's u prime divided by u. And that's all you need to do to differentiate a natural log. So for example, let's say if we have the function ln x squared minus 5x, and we wish to find the derivative. So the u variable is equal to what you see inside, which is x squared minus 5x. So u prime is the derivative of what's inside, or the derivative of x squared minus 5x, which is 2x minus 5. So using the formula u prime over u, it's 2x minus 5 divided by x squared minus 5x. And so that's how you can find the derivative of ln x squared minus 5x. Here it is. Now let's try some practice examples using that formula. So feel free to pause the video and try these. Go ahead and find the derivative of ln x squared plus 4 and 8 ln 5 minus 9x. So the derivative of x squared plus 4 is simply 2x. So that's u prime divided by the original function u, which is whatever is inside of the natural log function. So that's x squared plus 4. So that's the first derivative of ln x squared plus 4. Now for the next one, we have a constant in front. So our answer is going to be the derivative of ln 5 minus 9x times the constant 8. So the derivative of 5 is 0, and the derivative of negative 9x is simply negative 9 divided by what was inside. Now we can multiply 8 times negative 9. You can view this as 8 over 1. So this is equivalent to negative 72 divided by 5 minus 9x. So that's the answer for that one. Let's try some more examples. So what is the derivative of 5 ln x to the 4th and also ln x? So try these examples. So this is going to be 5 times u prime over u. The derivative of x to the 4th is 4x cubed, and then divided by the original x to the 4th. Now 5 times 4 is 20. So we have 20x cubed divided by x to the 4th. So we can cancel 3 x variables. So the final answer is simply 20 over x. Now what about ln x? The derivative of x is 1 divided by the original of what's inside. So the derivative of ln x is simply 1 over x. So we talked about how to find the derivative of natural log functions. But what about regular log functions? Here's the formula that you need. The derivative of, let's say, log base a of a variable u is equal to u prime divided by u, kind of very similar to a natural log function, but it's going to be u prime divided by u, but times ln a. So for the natural log function, the derivative was equal to u prime divided by u. But it's really u prime over u times ln e. But the natural log of e, remember that we have a base e here. The natural log of e is 1, so we don't need the ln e part. So it's simply u prime over u. But if the base is not e, then it's going to be u prime over u ln a. Now let's try some more examples. Let's find the derivative of log base 2 3x plus 4. So u is equal to 3x plus 4. U prime is the derivative of 3x plus 4. The derivative of 3x is simply 3, and the constant 4 will become 0. And a is equal to 2. So using the formula, u prime divided by u ln a, if we plug in everything that we have, we can see that u prime is 3 divided by u, which is 3x plus 4, times ln a, or ln 2, and this is the answer. Go ahead and try these examples. Log base 4, x to the 5th minus 9x, and also 7 times log base 3, 5x. So the derivative of what's inside is 5x to the 4th minus 9, using the power rule. And the original function u is x to the 5th minus 9x. It's whatever is inside the log function, times the natural log of this number, 4. Now let's do the same thing for the next one. So we have a constant in the front. Let's rewrite it. So it's going to be 7 times the derivative of this function. The derivative of the inside, 5x, is simply 5 divided by the original 5x times ln of base 3. So now we could simplify our work here. We can divide by 5. So the final answer is 7 over x ln 3. So now you know how to find the derivative of a log function and a natural log function. Now what we're going to do at this point is we're going to talk about how to differentiate exponential functions using an equation and also using the process of logarithmic differentiation. So let's use the equation first. The derivative of, that was supposed to be an x, e to the u is e to the u times u prime. So for example, the derivative of e to the 5x is going to be the same thing, e to the 5x times the derivative of 5x, which is simply 5. So for example, e to the 3 minus 7x. If we wish to find the derivative, it's going to be the same thing, e to the 3 minus 7x times the derivative of 3 minus 7x. The derivative of 3, which is a constant, is 0, and the derivative of negative 7x is simply negative 7. For e to the x, it's going to be the same thing, e to the x times the derivative of x, which is 1, which is equal to e to the x. Let's try a few more examples. So like 4 e to the negative x. This is going to be 4 times the derivative of e to the negative x, which is e to the negative x, times the derivative of negative x, which is negative 1. So this is equal to negative 4 e to the negative x. Now try this one, 9 e to the x cubed minus 7x. So let's rewrite the constant first, 9, and then the derivative of the e part is going to be the same thing, times the derivative of x cubed minus 7x. Using the power rule, the derivative of x cubed is 3x squared, and the derivative of negative 7x is simply negative 7. So this is the answer. So now that you know how to find the derivative of an exponential function using an equation, let's use logarithmic differentiation. So for example, e to the 4x, using the equation we know it's the same thing times the derivative of 4x, or 4. So let's prove it with logarithmic differentiation. So what you want to do first is say that y is equal to e to the x. The derivative, e to the 4x. The derivative of e to the 4x will be equal to y prime. But now, what you need to do next is take the natural log of both sides. By taking the natural log of both sides, we can take the 4x and move it to the front, which is a property of logs. So it's ln y, and that's equal to 4x times ln e. Ln e is equal to 1, so it's simply ln y is equal to 4x. So now at this point, we can take the derivative of both sides with respect to x. The derivative of ln y, using the u prime over u formula, the derivative of y is 1 divided by what's inside, which is y. And if you differentiate a y variable with respect to x, you're going to get dy dx attached to it. If you wonder why, just review implicit differentiation. The derivative of 4x is simply 4. So now, what we need to do is multiply both sides by y to isolate dy dx. So these two will cancel. So dy dx, which is the first derivative, is equal to 4y. Now remember, the original function y is equal to e to the 4x. So at this point, we can replace y with e to the 4x. And that's going to be 4 times e to the 4x, which is the derivative of e to the 4x. So that's how you can use logarithmic differentiation to differentiate an exponential function. So let's try another example. Let's say if we have the function e raised to the x squared minus 5. So we know the answer is going to be the same thing, e to the x squared minus 5 times the derivative of x squared minus 5, which is 2x. But let's use logarithmic differentiation to get that answer. So let's take the natural log of both sides. And then let's take the exponent and move it to the front. So it's ln y is equal to x squared minus 5 times ln e. Now we know that ln e is 1, so that disappears. And then it's ln y, which is equal to x squared minus 5. Now let's differentiate everything with respect to x. The derivative of y is 1 over y times dy dx, or you can write y prime if you want. The derivative of x squared minus 5 is simply 2x. So now let's multiply both sides by y, so that these cancel. So y prime, which is the derivative, is equal to 2x, which is right here, times y, and y is equal to e raised to the x squared minus 5. And as you can see, we get the same answer. Now what about if we have an exponential function that has a base other than e? Here's the equation that you need. The derivative of a constant raised to a variable is equal to the same thing, a to the u times u prime times ln a. So for example, the derivative of 7 to the 3x, so a is 7, u is 3x, is going to be the same thing, a to the u, or 7 to the 3x, times u prime, which is the derivative of 3x, and that's 3, times ln a, or ln 7. So try these examples. Let's say if we want to find the derivative of 7 to the 4 minus 9x, and 5 to the x squared. So this is going to be the same thing, 7 raised to the 4 minus 9x, times the derivative of 4 minus 9x, which is negative 9, times ln 7. Now for the next one, it's going to be the same thing, 5 raised to the x squared, times the derivative of x squared, which is 2x, times ln of 5. To try this one, let's say if y is equal to 4 raised to the 5x minus 9. Find the derivative using logarithmic differentiation. So we know the answer is going to be the same thing, times the derivative of 5x minus 9, which is just 5, times ln 4. But use logarithmic differentiation to prove that this is the correct answer. So let's begin. Let's take the natural log of both sides. And then let's take the exponent and let's move it to the front. So it's ln y is equal to 5x minus 9 times ln 4. Now let's differentiate both sides with respect to x. So on the left side, it's going to be 1 over y times dy dx. The derivative of 5x minus 9 is simply 5 times the constant ln 4. So now let's multiply both sides by y. So we can see that dy dx is y, which is 4 raised to the 5x minus 9 times 5 ln 4, which is what we have up here. Now let's try some harder examples. So let's say if we have the function y is equal to x raised to the x. So if you have a variable raised to another variable, how can you use logarithmic differentiation to find the first derivative? So just like before, we're going to take the natural log of both sides. This allows us to take the exponent and move it to the front. So it's ln y is equal to x times ln x. And at this point, we can differentiate both sides with respect to x. So the derivative of ln y is 1 over y times dy dx. Now for x ln x, we have a variable times another variable, or a function times another function, and we need to use the product rule. So the formula for the product rule, f times g is equal to f prime g plus f g prime. So let's say that f is x. That means f prime, the derivative of x, is 1. And if g is ln x, g prime, using the u prime over u rule, it's going to be the derivative of x, which is 1 divided by x, or 1 over x. So it's f prime g, f prime is 1, times g, which is ln x, plus f g prime, which is x, times 1 over x. So now let's multiply both sides by y. So dy dx is equal to y times ln x, and x times 1 over x is simply 1. X divided by x is 1. And finally, our last step is to replace y with what it is. That's x raised to the x. So dy dx is equal to x raised to the x times ln x plus 1. So this is the answer. That's how you do it. Let's try another example. So let's say that y is equal to x raised to the sine x. Feel free to pause the video as you work out this example. So let's take the natural log of both sides. So this will allow us to move the sine x to the front. So it's ln y is equal to sine x times ln x. So now let's find the first derivative. So on the left side, it's 1 over y times dy dx. The derivative of sine x, we're going to use the product rule again. So let's differentiate the first part, the sine x, which is cosine x. And then we're going to keep the second part the same. That's ln x, plus the first part times the derivative of the second part, which is 1 over x. So we're using the f prime g plus f g prime formula for the first derivative using the product rule equation. So now our next step is to multiply both sides by y. So dy dx is equal to y, which is x raised to the sine x, times everything that we see here. That's cosine x, ln x, plus sine x divided by x. So this is the first derivative. Now let's try one more example relating to this. Let's say if y is equal to 5 minus 4x raised to the 1 over x. So let's use logarithmic differentiation again. So it's ln y times ln 5 minus 4x raised to the 1 over x. So now let's move this to the front. So it's ln y is equal to 1 over x times ln 5 minus 4x. So now we need to use the product rule again. On the left side, we know it's going to be 1 over y times dy dx. Now, according to the product rule, let's differentiate the first part of the function. So how can we find the derivative of 1 over x? We need to rewrite it. 1 over x is the same as x minus 1. So now we can use the power rule, which is negative 1x, and then subtract this by 1. Negative 1 minus 1 is negative 2. So if you rewrite it, it's the same as negative 1 over x squared. When you move the x from the top to the bottom, the negative exponent will become positive. So it's derivative of the first times the second, which is ln 5 minus 4x, plus the original of the first, 1 over x, times the derivative of the second. To differentiate ln 5 minus 4x, we need to use the u prime over u formula. So that's the derivative of 5 minus 4x, which is simply negative 4, divided by the original 5 minus 4x. So now let's multiply y by both sides. So these two cancel. So dy dx is equal to y times negative ln 5 minus 4x divided by x squared minus 4 divided by x times 5 minus 4x. So these two you can combine because they're both on the bottom of their respective fractions. Now the last thing we need to do is replace y with this term. So therefore, our final answer for this problem is 5 minus 4x raised to the 1 over x times negative ln 5 minus 4x divided by x squared minus 4 over x 5 minus 4x. So this is it for this problem. Now let's go over some basic properties of logs. You need to know that the natural log of, let's say, a times b is the same as ln a plus ln b. Now ln a divided by b is very similar, but instead of addition, it's going to be subtraction. So it's ln a minus b. So because a is on top, it has a positive sign. And because b is on the bottom, it has a negative sign. And of course, you know this one, ln a to the second power is 2 ln a. You can take the exponent and move it to the front. So understanding these properties can allow you to find the derivative of difficult problems using logs. And sometimes using logarithmic differentiation could be a lot easier. So let's go over some examples. Now let's say if we want to find the derivative of x squared sine x. So we could use the product rule, or we can use logarithmic differentiation. But let's go ahead and do the product rule first. So the derivative of the first part, x squared, is 2x times the original of the second part, sine x, plus the original of the first part times the derivative of the second part, which is cosine x. So this is the answer. If we want to, we can take out the GCF, which is x, and write it as 2 sine x plus x cosine x. Now let's see what we're going to get if we use logarithmic differentiation. So let's take the natural log of both sides. Now, using the properties of logs, we could separate the x squared and the sine x by writing two natural logs separated by addition. So it's ln x squared plus ln sine x. Now, if we want to, we can take the 2 from ln x squared and move it to the front. So this is ln y, which is equal to 2 ln x plus ln sine x. So now we could find the first derivative of both sides. The derivative of ln y is 1 over y dy dx. The derivative of ln x is simply 1 over x, but times 2. And the derivative of ln sine x, the derivative of sine is cosine divided by the original sine. So now let's multiply both sides by y. So dy dx is equal to y times 2 over x plus cosine over sine. And y is x squared sine x. Now for this particular problem, it turns out that logarithmic differentiation is actually a longer process. Other times, logarithmic differentiation can be a shorter process. You have to decide which route is easier. Now let's distribute x squared sine x. So 2 over x times x squared sine x, one of the x variables will cancel. So it simply will be 2x times sine x. Now once we multiply x squared sine x and cosine x over sine x, we can see that sine x will cancel, and it's just going to be x squared cosine x, which is the derivative using product rule. This is the same exact answer that we have, and we could take out an x if we want to. Now let's try another example. So let's say if y is equal to x cubed times the square root of 5 minus 9x. So you can use the product rule or you can use logarithmic differentiation. Let's try both, since the title of this video is logarithmic differentiation. Let's use the product rule first. So f is x cubed, and f prime, which is the derivative of x cubed, that's 3x squared. G is 5 minus 9x raised to the 1/2, if you rewrite it. And g prime, using the power rule, is going to be 1/2, and then keep the inside the same, which is 5 minus 9x, and then 1/2 minus 1, which is 1/2 minus 2 over 2, that's negative 1/2. And don't forget to differentiate the inside, or the nested function, because this is basically a chain rule problem, so to speak. The derivative of 5 minus 9x is simply negative 9. So g prime, if you rewrite it, it's a negative 9 divided by 2 times the square root of 5 minus 9x. So because we have a negative exponent, we need to take this term, move it to the bottom. And when you move it to the bottom, it's going to be 5 minus 9x raised to the 1/2, which is basically the square root of 5 minus 9x on the bottom. Now, let's use the product rule. So we know it's going to be f prime g plus fg prime. So f prime, the derivative of the first part, is 3x squared times g, which is the original of the second part, and that's square root 5 minus 9x, plus f, which is the first part, times the derivative of the second, which we know to be negative 9 over 2 square root 5 minus 9x. So this is the answer. If we want to, we can get common denominators. So what we can do is multiply the second fraction by 2 radical 5 minus 9x. Now sometimes, dependent on your teacher, you may not have to simplify it, but in some exams you may actually have to simplify it. But if you need to simplify it, this is what you should do. So now that we have the same denominator, let's multiply these things on top. So 3x squared times 2 is 6x squared. The square root of 5 minus 9x times itself is simply 5 minus 9x. The square roots will disappear. So for example, the square root of 4 times the square root of 4 is 4. 4 times 4 is 16, and the square root of 16 is 4. So you just get what's inside, divided by what we have here. And then minus 9x cubed times 2 radical 5 minus 9x. So now that we have the same denominator, if we want to, we can combine the numerators. But let's distribute the 6x squared to these two terms first. So 5 times 6 is 30, so it's 30x squared. And 6 times negative 9 is negative 54, but x cubed. And then minus 9x cubed divided by the same denominator. Negative 54 minus 9 is negative 63. So this is the answer if you wish to combine it into a single fraction. But now let's use logarithmic differentiation to see what kind of answer we're going to get. The answer might be in a different form, but it's still mathematically correct. So let's begin by taking the natural log of both sides. And now let's separate x cubed from the square root of 5 minus 9x, which at this point it's wise to rewrite it like this. So now let's take the exponents and let's move them to the front. So ln y is 3 ln x plus 1/2 ln 5 minus 9x. So now let's find the derivative. For the left side, we know it's 1 over y times dy dx. The derivative of ln x is 1 over x. And for 5 minus 9x, it's going to be the derivative of 5 minus 9x, which is negative 9 on top, divided by the original. Now let's multiply both sides by y. So dy dx is equal to y, which is x cubed square root 5 minus x times everything that we see here. So that's 3 over x minus 9 divided by 2 times 5 minus 9x. Now if we want to, we could distribute x cubed square root 5 minus 9x, but it's best to leave the answer like this. So we're going to stop here. Now let's try this example. So we could use the quotient rule, but we're not going to do that. We're just going to use logarithmic differentiation. So let's take the natural log of both sides. And then let's separate 5 minus 2x from x squared plus 4. Since it's division, we're going to separate it into two natural logs using subtraction. So it's ln 5 minus 2x minus ln x squared plus 4. So now let's find the first derivative. So it's 1 over y times dy over dx. And the derivative of ln 5 minus 2x is going to be the derivative of the inside, which is negative 2, divided by 5 minus 2x, minus the derivative of x squared plus 4, which is 2x, divided by x squared plus 4. So now the last thing to do is replace, or first multiply both sides by y, and then replace it with what we see here. So dy dx is equal to y, or 5 minus 2x over x squared plus 4, times negative 2 over 5 minus 2x over x squared plus 4. So that's how you can use logarithmic differentiation instead of the quotient rule if you want to find the derivative of a fraction or a rational function. Let's try one more example. Feel free to try this one and pause the video, work it out, and see if you'll get the right answer. So for this, you don't want to use a quotient rule because you have the quotient rule combined with the product rule, power rule, and the chain rule all wrapped up in one problem. So this problem is definitely a good candidate for logarithmic differentiation. Now let's take the natural log of both sides. Now instead of writing cube root 9 minus x squared, I'm just going to write it as 9 minus x squared raised to the 1/3. And now let's separate everything. So instead of writing ln x squared, we can move the 2 to the front. And, well, actually, I'm going to take it one step at a time. I'll do that later. So it's ln x squared plus ln 6 plus 3x raised to the 4th. And then minus, since this is on the bottom, minus ln 9 minus x squared raised to the 1/3. So now what we're going to do is take the exponents and move them to the front. So it's ln y, which is equal to 2 ln x plus 4 ln 6 plus 3x minus 1/3 ln 9 minus x squared. Now let's find the derivative. So it's going to be 1 over y dy dx. The derivative of ln x is 1 over x. And for the next one, it's going to be the derivative of the inside. The derivative of 6 is 0, and for 3x is 3, divided by 6 plus 3x, minus 1/3. The derivative of 9 minus x squared is just negative 2x, divided by what was originally inside. So now let's multiply both sides by y. So dy dx is equal to y, or basically this stuff, x squared 6 plus 3x raised to the 4th times the cube root of 9 minus x squared, and then times everything that we see on the bottom. So that's 2 over x plus, I guess we can cancel 3. We could divide each of these terms by 3. So that's 1 over 2 plus x. And if you multiply the top by 4, it's going to be 4 over 2 plus x. And then plus, the two negative signs will cancel. So plus 2x divided by 3 times 9 minus x squared. So this is the final answer. So now you know how to use logarithmic differentiation to differentiate exponential functions like e to the x or 4 to the 2x. You know how to use it to differentiate a function that has a variable raised to a variable like x raised to the x or x raised to the sine x. And now you know how to avoid using the product rule, quotient rule, and things like that using logarithmic differentiation. So that is it for this video. Thanks for watching and have a great day.